Welcome to the Screencast-O-Matic video versions of the notes for linear regressions and how they work. So we're going to put some vocabulary on this topic. The least squares method is a standard way to find a regression line. And we start with a line that passes through the average or mean values of each variable. Next, we find the line for which the vertical distance between the data points and the line is minimized. And for simplicity, the distance is treated as positive or absolute value only. Okay, so we're going to start by finding the average height and the average shoe size. So if we add those up and divide by 3, we get a 71. If we add the shoe sizes up and divide by 3, we get a 10. So let's kind of sketch in a line that looks kind of like the line that we're looking for. And we know that that line has to pass through the point with the average values. And so the average values is 10 and 71. And you'll notice that we've kind of flipped x's and y's here. So the 10 is on the horizontal axis and the 71 is on the vertical axis. So let's sketch a best fit line through that point. And what we're trying to do is we're trying to find these vertical distances between the data points and our line. So let's first make a conjecture about what the equation of this line is. And we know a lot about this line, except we don't know the slope. So we're going to use point slope form. Y minus y1 is equal to m x minus x1. And we know that our line has to pass through y1 is 71, x1 is 10. So y minus 71 is equal to m x minus 10. And if we rearrange that, we get y is equal to m x minus 10 plus 71. So now we're going to go about calculating the value of each of these points, the y value, and then we're going to subtract that value from the data point values. So the residual at point 1, which is 8 and 68. And so we're going to plot the line value y at x is equal to 8. So y is equal to m times 8 minus 10 plus 71. So with that can simplify to y is equal to negative 2m plus 71. Now to find that residual, I'm going to call that delta y. We're going to say 68 minus the line value of y, minus 2m plus 71, and that simplifies to negative 3 plus 2m. So that's our first point. Our second point where x is equal to 10, we can actually read right off the graph because our real data point is at 1070, so the vertical distance between 1070 and 1071 is delta y is equal to 1. Now, the residual at point 3. And that's x is equal to 12. So y is equal to m times 12 minus 10 plus 71, which is 2m plus 71. And our delta y is 75 minus 2m plus 71. So our delta y is equal to 4 minus 2m. Okay, now we have our three residuals, and we're going to set up a variable where we find the area of squares that are composed. I'll kind of draw these little squares here. We played with this a little bit in class. The square of the distance, so it's that vertical distance squared. And we have a vertical distance here, so we can draw what looks like a square there, and a vertical distance with a little itty bitty square right here. So we're going to set up a variable t that's going to be each one of these distances squared added up. And if we FOIL all that out and add everything up, we get 9 minus 12m plus 4m squared plus 1 plus 16 minus 16m plus 4m squared, which adds up to, I believe, 8m squared. Have a 12m and a 16m. So that's minus 28m plus 25? 26. Okay, so now to minimize the areas of these squares, we're going to take, with respect to the slope, we're going to take dt over dm, which is 16m minus 28, and we're going to set that equal to 0. So if we solve for m, we get 28 over 16, which is 7 over 4. So our slope on that line is 7 over 4. So we can say, we now have that equation for the line. Y is equal to x minus 10 plus 71, and with that slope. So if we mess around, distribute the 7/4 minus 70 over 4 is 35 over 2 plus 142 over 2. We get y is equal to 7/4 x minus 107 plus 107 over 2. So what I would encourage you to do at this point, matter of fact, I will do it, so I'll be back in just a second. Okay, I've gone on ahead and put our data set into the Navigator system, and I have created, let me turn off the ink here. I have created the data points and the graph. I'm now going to go ahead and put analyze graph, regression, and regression equals a plus bx. So I get 53.5 and 1.75x. So if we go back to our equation, that's a terrible line. If we go back to this equation, 7 over 4 is 1.75, and 107 over 2 is 58.5. So the regression that we calculated matches the regression that the calculator calculates. So I hope you've enjoyed this cleaned up version of the example of least squares regression.